are highly welcome to another exciting edition of Mathematics Being Made Easy. Here our goal or our mandate is to ensure that we make mathematics user-friendly or very friendly to students. Today we want to look at the quotient rule, how the quotient rule came about. I quite remember that I did a video on quotient rule and a lot of students are saying that we have to prove the formula so that even if they forget the formula, they will be able to prove it. So I thought it wise that it would be good to prove the formula. So let's dive in and prove the formula. We know that for quotient rule, the general formula given is what? Changing y over changing x is equal to v du over dx minus u dv over dx all over v squared. This is the general formula normally we use to solve differential equations involving what? Involving a fraction, or that relates to what? Quotient rule. This is the formula we use. But how did the formula come about? That is what we want to prove. So we know that if a function is given to you and the function is in a fraction form, for instance, we have y is equal to 2x over 3x plus 2. This is a fraction because we have a numerator and then the denominator. So when it happens like this, we use the quotient rule. Quotient rule, that is what we normally use to solve it. Now, let's take the y, which is equal to u over v. The u that we have here is a function of x. Say u is equal to what? The numerator 3x plus 2 is a function of x. So when we differentiate it, we'll have what? With respect to x, we'll have du over dx giving us 2. I hope you are getting it. But in this form, in this case, we don't have the function given, but we have u. So you need to know that the u is just a function of x. Are we getting the point? And when we differentiate the u with respect to x, this is what we'll be having. Du over dx. So if that being said, let's move forward. So this is if the function is in a fraction form, we use it. We use this thing. So what we normally do is that, now let's get into the proving. So this formula can be changed. We can equally write it this way. y is equal to u v prime indices. Y is equal to what? U v an exponent of -1. So what do? If we also have a fraction in this form, what rule do we use? We use the product rule because the u is multiplying the v now. There is a dot here which is what? Multiplication. But I didn't write it. So u is multiplying the v -1 as well -1. So we use the product rule. What does the product rule say? It says that we should hold one of the variables, differentiate the other. Then we now hold the second one, we differentiate the first one. I hope you are following. Now let's differentiate with respect to what? X. So dy, changing y over changing x will be equal to what? We differentiate u, or we hold v exponent -1, and we differentiate u. How do we differentiate u? So we hold the v. So v -1. Now we differentiate u. When you differentiate u, you get what? Du over dx. As I said early on. Then added to, we now keep the u and differentiate v. So u, we differentiate v. So in differentiation of v, when we are differentiating v, we use, have you seen the way it is? We use a rule, and that rule we call it the chain rule. If you don't have any idea about the chain rule, kindly check my videos on chain rule. You'll find how we differentiate functions using the chain rule. So when we are differentiating this function, you have to what? Drop the 1. So we have -1. We drop it. Now we differentiate the v itself. The whole of this can equally be written as the v -1, mind you, can be written as v exponent -1. I believe you are getting the point. This can equally be written as this. It's the same thing. So what we are differentiating is that when we are differentiating this function, you drop the what? Negative 1 as we have. Now differentiate what we have in the brackets. What do we have in the bracket? We have v. So when we differentiate v, we'll get what? dv over dx. Then we repeat the bracket v. Then we subtract 1 from negative 1. When we do that, we'll have negative 2. Negative 2. I hope we are following. Good. We are following. Good. So now our dy, our change in y, our change in x is equal to, we have this. This is the same as what? This is what? This is v negative 1 multiplying du over dx plus, when we multiply the whole of this, we have what? Negative, we have negative what? So the negative overpower, so we have negative u bracket open dv over dx, giving us what? V multiplied by v negative 2. So multiplying v negative what? 2, negative 2. So what we have, we can drop this thing. We can rewrite v negative 1, v exponent negative 1 and v exponent negative 2. What are we going to get? So we have our dy over dx is the same as what? This can be written as du over dx all over what? V. And this can be written as u dv over dx all over what? V squared. I hope you are following. Okay. So we need what? The LCM. The LCM is what? Is V squared. So we have the LCM being what? V squared here. Now V will go here. It will go here. We have this, the V squared is what? V multiplied by V. So this V will cancel 1. So we are still left with V. So that V will be multiplying this. So we have V multiplying du over dx minus V squared will go into V squared 1. 1 times the whole of the numerator, u multiplying dv dx. It will give us the same thing, u dv over dx. So this is how the formula came about. When we differentiate y is equal to what? U over v. This is what we have. So we've been able to prove that this is this when we differentiate. So this is the formula we normally use to what? To solve questions relating to what? Quotient rule. V du over dx minus u dv over dx all over v squared. So this is the formula. Thank you very much for being part and parcel of this lesson. I pray and I hope that you find this and you watch it critically, you understand. I also pray for your indulgence that you help push the video to those that are in SHS or those that are in the universities, because we equally have these things in the university. Those that are in SHS and universities, so that they will look at it and learn from it, and this will make their journey in mathematics extremely easy. Thank you so much. Hit the plus button to subscribe, and also like, comment, and share the video. Let it go viral. Very soon I'll be starting another series on what? On sets on my YouTube channel. Kindly visit that channel also and subscribe. Let's push this content to the greater, so that it can reach the greater masses of the people. Thank you so much. Bye bye for now.